Hello, my name is Oliver Pickard and welcome to beautiful Limousin, France. In the past I've made videos about the basics of suspension and the basics of tyres, and today I'm going to meet them in the middle and make a video about the basics of wheels. And all of the myths and all of the legends and all of the misconceptions hopefully will be debunked in this video. Now, when you are making a vehicle like Pandora, you start off with the tyres and you find the correct size of tyre that's available, because obviously you have limited availability. So you find the right size that you want, and then you find the right wheels to match that right size tyre, and then you go from that to brakes to suspension, and you work your way inwards. You design your car from the wheels in. And I started my journey with Pandora with the simple philosophy of, I don't know what I don't know. I know what I know, but I don't know what I don't know. Does that make sense? So I went out onto the internet and I thought, I'm going to learn as much as I can about wheels, and as much as I can about everything. And I'm going to assume that I know nothing, and I'm going to start from there. I'm going to start from humility. And what I was greeted with was a bunch of videos by people trying to sell me wheels. And not necessarily what I was looking for. These people obviously had what the Americans refer to as skin in the game. They were salesmen, and so the information that they gave isn't necessarily, I don't want to say not true, but not necessarily correct. So today I'm going to go through from the most basic style of wheel to the most kind of not advanced style of wheel, but the most complicated style of wheel that you'll find on a modern car. I'm not going to do old-fashioned wood wheels. I'm not going to do spoked wheels. I'm sorry, pre-war car people. I keep buying wheels. I've got a bit of a wheel addiction. I'm not a salesman. I'm just a man who owns too many wheels. And today I'm going to use those wheels and show you basically like I say, from the most simple sort of wheel to the most complicated sort of wheel, and everything in between, and hopefully along the way you might learn something, and you might just be entertained. So the first thing is, this is a steel wheel. This is actually one of the winter wheels from my 2CV, and it has a Michelin snow tyre on it. Now, what makes this a steel wheel? Well, the centre is steel and the rim is steel. And in the 1960s, you'll also find some wheels called bimetal wheels, but they aren't massively common and they don't exist anymore for the reason that that was an aluminium centre and a steel rim. And they discovered that when salt got involved, the aluminium and the steel used to kind of react to each other. The aluminium would lose and corrode, and then your wheel rots away, and it's just a bad case all round. So you don't find those anymore, and what you will find is steel wheels or alloy wheels, and never the two shall meet ever again, hopefully. But steel wheels are actually brilliant. People tend to do them down. People tend to say, oh, steel wheels are cheap, but steel wheels are actually fantastic, and they are repairable. You can bend a steel wheel massively and repair it, fix it. You can bend the centre, and with the correct tools you can actually straighten the centre of the wheel, and you can bash the living hell out of the rim. So say you have a flat tyre, you have a fatal puncture, and you end up on the rim and you bend the rim down. With a bit of skill and a hammer and some wood, you can actually bend it back again and have it exactly as good as new, because steel can take a hell of a lot more punishment than an aluminium wheel can. Now we're going to have our first bit of jargon. Now, the bolt pattern of a wheel is called a PCD, which stands for pitch circle diameter. So, say, use the example of an Alfa Romeo wheel, because this is a 3-bolt wheel and it's not massively common. An Alfa Romeo wheel, or a Talbot Simca wheel, or a lot of Chrysler wheels, or stuff like that. Some Peugeot wheels are referred to as 4 by 98, right? That is a 98mm circle with 4 holes in it. Simple as that. So if you have a 5 by 140, which I think is Porsche, or is that 5 by 130? Can't remember. Anyway, that would be a 130 or a 140mm circle with 5 bolts in it. It's that simple. That's what a PCD is. And if you are looking for wheels for your car, the first thing that you need to know is what PCD your car is, and that's easy to look up online. Right, I'm going to get rid of this now because even though it's awesome, it's not what people normally think of when they think of a steel wheel. Now, the cool thing about steel wheels, another cool thing is, this is welded to this. This one is spot welded here, and here, and here. Which means you can actually undo those welds, and in theory, you can weld any width of rim onto your incredibly strong steel centre. And that looks a little bit like this. This is a 10-inch banded steel. And this is what came on a bunch of things like the early Mini Cooper S and what would originally come on a Cox GTM like Pandora. This actually isn't a mini wheel, as you'll notice from the tiny PCD. This is off a trailer, but it is, for all intents and purposes, very, very similar. And it has a huge fat tyre on it. It's a super cool looking wheel, which is why I chose it for this particular video. Now, one of the main myths behind steel wheels is that steel wheels are not as good as alloy wheels, and they are not as strong, and they are not as light, and they're not as good in any way, shape or form because they are cheap. They are cheap. And you can get banded steels for a bunch of different cars, a bunch of a lot of drift races, like grassroots drift guys in Europe love banded steels. They buy, what are they, Opel, Opel Buick steel wheels, and they have them banded and they put them on BMWs and stuff, and they look awesome, and they use them because they're really cheap and they are really, really strong. But like I say, one of the myths is that steel wheels aren't light. Now, steel wheels may not be as light as the lightest of aluminium racing wheels, but in a grassroots situation, so your average, your average guy with his car, a steel wheel is actually an incredibly competitive weight or net when compared to an aluminium wheel, and will actually be a lot lighter than a giant chrome snowflake thing. The giant, what do you call them? The big chavvy wheels. A small steel will be a lot lighter than a big alloy wheel. And one of the other myths is that steel wheels aren't strong. Steel wheels are massively strong. Like I say, you can beat the hell out of them and you can repair them up to a point. The other myth is that bigger wheels are better. Now then, this is a mini wheel. This is a mini light. Move that over there. Right. This is a mini light. This is a 12-inch mini light, and this is a 10-inch wheel. Now, the first thing that you'll notice is that these wheels are incredibly similar size. That is what is referred to as the rolling diameter. So that is the diameter of wheel plus tyre. Now, these wheels are incredibly similar weight, believe it or not, including the tyre. The steel is slightly heavier, but it is also considerably wider, which is big. So that obviously adds weight because the tyre is much heavier, and obviously a wider rim is going to be heavier as well. Now, one of the myths is that you're always better going for a bigger wheel with a lower profile tyre, because that's faster apparently, but not necessarily the case. So for example, on a Mini has not a ton of suspension travel, and this big thick sidewall here can actually form part of the suspension unit. You can use tyres as suspension, which Formula 1 cars have been doing for a really, really, really long time, and it works incredibly well. So we know these wheels are a similar strength. This is a sand cast aluminium wheel, by the way, which is the most simple form of alloy wheel. I'll go into more detail in that in a moment. But we know that these wheels are similar strengths. We know that these wheels are similar weights. So why would you go for a 12 over a 10? Well, there's a lot more room in the back of this wheel. These are a bit rough looking. I know they were covered in white hammerite, and I've been systematically stripping it all back and making them look pretty, ready to put them up for sale. I might just keep them though. But you'll see there's a lot more room in the back of this wheel than there is in the back of this one. which means you can put much bigger brakes. So on a heavier vehicle, you'd be better off with the 12 because you've got a much better chance of stopping it repeatedly. Now, because you can fit a bigger disc, and a bigger disc cools better and all of that. But of course, a bigger disc weighs more. It's this thing where once you start adding, you have to keep adding. So you have a bigger wheel, which in the same width, the same size wheel with the same size tyre, I actually think that this wheel would be heavier than this one. In the same width with the same width tyre. And then you put a bigger brake in it, so you've got a heavier brake disc, and you've got a bigger brake caliper, and that weighs more. And so you end up adding weight and adding weight. But if your vehicle weight, so if you have a later Mini which is much heavier than an earlier Mini, you may need bigger brakes, and you may need a bigger wheel to fit your bigger brakes. But forget the brakes for a minute. Which of these wheels is actually faster? Now that might sound like an odd thing to say, but in theory, this 12-inch wheel with this lower profile tyre on has a slightly larger rolling diameter. So the overall diameter of the wheel is slightly larger than this one, which means theoretically this wheel has a slightly higher top speed. This wheel will accelerate, the small wheel will accelerate faster, whereas the bigger wheel will have the higher top speed, meaning for the same gear, so in fourth gear in a Mini, you would turn slightly lower RPM for the same speed with this wheel than you would with that wheel. So let's talk about alloy wheels, because they aren't all made the same. They aren't all equal. I nearly dropped that then. So, aluminium is of course an alloy. It is a cocktail, a melange, if you will, of metals. Predominantly aluminium, but there are also magnesium wheels. Magnesium wheels are predominantly magnesium, and they are much, much lighter, and you'll find them on racing cars. But most alloy wheels are made predominantly of aluminium, but not all alloy wheels are made of the same stuff. There's a bunch, literally hundreds of cocktails of aluminium. And they all have different properties and different qualities. So, for a start, the material your wheel is made of can be different from another wheel, even if they look similar. And there's different methods of making wheels, but I'll get into that in just a moment. So let's just talk about retro wheels for a minute and buying second-hand wheels, because this is something that people don't talk about. Aluminium and magnesium age and work harden, meaning the older an alloy wheel is, the more brittle it becomes and the more likely it is to crack or snap. This is a massive consideration with magnesium wheels, but it is also a big deal with alloy wheels. And I commonly see people on forums and stuff talking about wheels made in, let's just call them fake wheels, shall we? Wheels by companies who aren't the company who originally designed that wheel, reproducing a wheel in a far-flung country for much less money, but also of much lower quality. And a lot of people on forums discussing fake wheels often talk about, oh, you're much better off buying a second-hand set of quality wheels than you are buying a new set of fake wheels. But they don't take into consideration the fact that aluminium age and work hardens. And you might think, well, how bad can that be? When they make aeroplanes and they skin an aeroplane, which they do in aluminium, they actually colour code the rivets. And they change the boxes of rivets throughout the day, because the rivets at the end of the day, if you started the day with a box of rivets and that box lasted till the end of the day, there would actually be a different hardness at the end of the day than they were at the beginning of the day. So, depending on the mixture of aluminium, it can actually harden within like 12 hours. Crazy, yeah? That means that if you buy a retro set of wheels, they are much more prone to cracking than a brand new wheel would be, even if they are made of the same mixture of aluminium as a brand new wheel. Just the fact that they are older and that they have been on a car means that they are much more prone to cracking, which is one of the great things about the fact that a lot of wheel makers, such as BBS and a lot of the Japanese companies that make wheels, and Gotti and all sorts, they're all, and of course Mini Lights, they're all still making wheels. So if you're building a car and you're going to be putting tons and tons of power through some incredibly sticky tyres, and you're going to be doing track days and stuff, and you're going to be driving hard, you might do well to go out and buy a brand new set of retro wheels rather than a second-hand set of retro wheels, as cool as retro wheels can be, because like I say, they're much, much stronger when they are newer. But that of course depends on how they were made, when they were made, and the life they've had, and also the quality of the wheel to begin with. Now, this is a sandcast wheel, and a sandcast wheel is very simply, you get a sand pit of, like you played in as a child. It hits a box with sand in it, and you press a mould, and it's special sand, it's casting sand, which is super dry and super fine, but you press a mould into that sand and you leave an imprint, and then you put a top on it, which is also made of the same stuff. That's just sand that you've pressed a mould into, like that. Sandwich them together, you inject or you pour in aluminium, and you get a sandcast wheel. It is reasonably light, it is reasonably strong, but on a molecular level, your grains of aluminium are pretty much all in different directions and are all doing their own thing, which means that they aren't consistently strong throughout the wheel, and those inconsistencies are not the same from wheel to wheel. So basically, the molecular structure of your wheel isn't uniform. And they're strong, but they're not as strong as they can be. And there's a bunch of different ways to make an aluminium wheel stronger in the production process. So for example, one of the common ways of doing it now, and it's a new technology, is called a floor form wheel. There's a bunch of different names for it depending on a certain person's, trademark. But what a floor forged wheel is you cast your wheel, just as a normal sand cast wheel, and then you grab that casting and you put it in like a lathe, like I have behind me, but it's vertical basically, and you spin it up super fast, and then with pressure and a big die you force the shape of the rim into that aluminium casting and mould it through pressure and centrifugal force, making the aluminium all line up, making all those molecules all line up in the same direction, making the wheel stronger. It's not a fully forged wheel because the centre of the wheel doesn't get as hard as the edge of the wheel, but the part of the wheel that takes the most abuse, the lip and the barrel, obviously becomes super strong. The stronger version still is what is called a forged wheel, and a forged wheel is one of two ways. One, it is kind of pounded and cast at the same time to make a wheel where everything lines up, and the other way of doing it is what's called a billet wheel. Now, right, billet, this is another big misconception, another big myth. Everyone thinks that all billet is forged. What billet means is, a billet is a block. So an aluminium billet is literally a block of metal. It doesn't have aluminium. It doesn't mean it's forged, doesn't mean anything. It just means it was made from a block. That's what billet means, right? Forged billet is a block of metal that has been smacked and heated and made under massive pressure to create a block that is super strong. You can also cold forge, which uses massive pressure rather than heat to also line up that molecular structure in that block. And then you take that big block and you cut a wheel out of it, which is obviously massively time consuming and massively expensive because your raw material's expensive, and then you're putting a bunch of time into it, a bunch of machine hours. Wheels aren't made by people anymore, it's all computer controlled CNC stuff. But basically made in a machine, cut out, but it's all machine hours and it's all time and wear on machines and stuff like that, so they're really expensive, but they are super strong. And a floor form wheel is kind of in the middle between a sandcast wheel and a forged wheel. It's kind of a semi-forged wheel, but they are a lot cheaper than fully forged wheels. Now, speaking of forged wheels, a lot of forged wheels are what is called multi-piece wheels. And this is a multi-piece wheel. This is a two-piece wheel, meaning that the barrel, this bit, and the centre are separate, and they're held together with these big Allen bolts. This is a wheel from a Renault Alpine, and it's made by a French company called Gotti, who have won a few World Rally Championships in their time. Like I said, Gotti are one of the preeminent multi-piece wheel makers in the world, and they often get overlooked because people don't speak French. But every Renault and every Alpine that has won a Monte Carlo rally or a world rally has had a set of Gottis on, pretty much. They are incredibly high quality wheels, and they are absolutely lovely, which is why I bought these, even though I don't have a car to bolt them to. And these are 14s. So that's a 14 by 7, right? And it's only slightly heavier, but it's almost the same weight, if we took the tyre off, as this 12-inch wheel. Even though it's much bigger and it is massively stronger. Now, what are the benefits of a multi-piece wheel like this? Well, for a start, we touched on it in the beginning, but damage. If you damage, so if you have a puncture and you smack the rim while doing a rally of your multi-piece wheel, you can take the centre of the wheel out and replace the rim. Great stuff. You can see here on the back, I've actually loosened these bolts off, but there are big bolts, and you undo the bolts and you separate the rim from the centre and simply pop another rim on. And earlier I talked about offset. Now you can actually see that these wheels have a huge offset. Okay, offset is really simple and everyone makes it sound really complicated. What offset is you get your wheel and you measure it from point to point and you find your centre point of the width, right? And it is the relationship between the centre point and this back section of the wheel. So you measure from that back to here and the back to the front of the wheel, and that will give you your offset in millimetres. And this is of course plus or minus whatever that number may be, and it depends on the width of the wheel and what that wheel was made for, but it's measured from this back surface here, and it's super easy. But this isn't, a two-piece wheel isn't kind of the height of motorsport's awesomeness. A multi-piece wheel, by the way, isn't necessarily stronger than a forged cast wheel. A forged cast wheel will always be lighter and may be stronger, but it's negligible, but it will always be lighter. Whereas a forged multi-piece wheel is often used in motorsport because of convenience, because of the ability to carry spare parts, and because of the ability to, like I say, choose your different offsets, because you can get your centre and your wheels at the front might be the same centres as your wheels at the back. So if you damage a wheel, you can take one of your spare front wheels and put a rear barrel on it, because the front and the back of the car may have different offsets. So like I say, it just makes wheels massively repairable in the field. But what about a three-piece wheel? This is a three-piece wheel. This is a 13-inch three-piece wheel. So let me line these up. I should have thought about this and gotten a wooden chock, but I didn't. So 12, 13, 14, and I'm going to lie that down before it falls. Now, this 13 is loads lighter than this 12. This is one heck of a wheel. This is another Gotti. This is an earlier Gotti, and this is from a BMW 2002 rally car. And I've actually removed the bolts that run around the edge, but it has these really big aluminium, this one has stainless steel wheel bolts that go all the way around that hold the three pieces together. So this is a two-piece, rim, centre, and this is a three-piece. And what that means is it has a centre that looks like this, right? And then it has a front rim and it has a back rim. And you can actually see the lines here. And there's actually some rubber O-rings that go in between the sections, and then it's all clamped together, which makes it obviously super strong. But they're also incredibly light and really easy to repair. So like I say, if you're in a racing car and you happen to damage a centre for whatever reason, or you damage the outside of a rim, you can just replace it. Really, really simple. The other benefit is that say you have, I don't know, say you've just bought a car and you need a much wider rim. So with this you need a full rim, and if you damage the front of the rim you need to replace that rim. But what if your racing car has this piece the same but this piece different? Well, in a two-piece wheel you'd have to replace the full thing. Whereas if you damage the front, then only the front's damaged and you just replace it. But if you need a wider section, you can simply grab a wheel like this, which has, this is a Martini formula wheel. It has the same centre as these Gottis. It is again a Gotti, but this is not from a BMW 2002. This is a full-blown Martini formula wheel, right? From like a Formula Junior or a Formula whatever. Formula, what do you call it? Formula Atlantic, something like that. Now, this wheel weighs the same as this again. Or maybe slightly less. It weighs a lot less than this does, but it is, without a doubt, the strongest wheel here. These two wheels are the same strength, despite this wheel being much bigger and much wider. And, like I say, they are technically the same wheel. The only difference is that this outside rim, this is a 6-inch wheel, and this is a 9-inch wheel. So actually we can go 6, 7, 9. And you'll notice that the lips, this beaded edge, is much thinner on these wheels, and that's because it is a much stronger lip. And it's a much lighter wheel, tons and tons lighter. But a multi-piece wheel isn't necessarily, like I say, the strongest wheel, but it is the most user-friendly wheel as far as racing is concerned, which is why a wheel very, very similar to this was put on Group B rally cars, and also Jim Reniotti's Renault 5 Alpine Turbo Monte Carlo rally winning car, and cars like Formula Atlantics and stuff like that. It is one hell of a strong wheel, but very, very expensive, and it's obviously had quite the life. It's been used, it's been abused, as has this Gotti BMW wheel. It's had one hell of a life, but because it's such a high quality wheel to begin with, it's still incredibly strong. Another myth is contact patch and width, that a wider wheel is a grippier wheel. Well, that's not necessarily so. This is a 14x7 and this is a 13x8. But believe it or not, these two wheels, even though this is a narrower wheel, have the same size contact patch. They're just different shapes. A 13 has a more rectangular sausage-shaped contact patch, and this bigger 14 will have a squarer contact patch. That is all things being equal. But, as we know from these two wheels, all things are not generally equal, because you may have a much lower profile tyre on here, which wouldn't give you as much grip in that contact patch. So it's not just about the size of the contact patch, it's about the quality. And the quality of the grip. And the quality of the tyre. So it's much, much more complicated. Another thing to consider is that because these wheels are huge, this wheel turns much slower than... Get rid of this. This wheel turns much slower than this one. In fact, tyre companies will give you revolutions per mile. And if you want to work out your overall rolling diameter, you can actually look up your tyre wheel combo online. There's a bunch of really good tools. I was taught to do it with maths when I was a kid, but there's a bunch of free tools online that you can just put in your tyre size, put in your wheel size, and it will spit out your rolling diameter and also your revolutions per mile. So, at the same speed, or revolutions per kilometre, so at the same speed, this wheel is travelling much faster than this one. Meaning that when you turn into a corner and you apply the, or you turn in, apply the brakes, this wheel is spinning slower and carrying less momentum, but may be the same weight as this one because this is much lighter. See, it's very confusing. But this wheel is actually, at the rear, is travelling much faster. So if it was heavier than this one, then the car might actually oversteer. Which is why a lot of companies put larger wheels on the back. Cars like the Lotus Evora has a 19 on the front and a 20 on the back. The Renault 5 Turbo 2 has a 13-inch wheel on the front and a 15 on the back. A lot of rally cars did it. And a lot of 350Z and also Honda S2000 owners also put staggered wheel setups so that the back wheels are spinning slower than the front wheels, so that when you turn in, you chuck it into a corner because your back wheels are spinning slower, then the car has less tendency to oversteer, which you can also do by having a bigger sidewall. So it's not just about wheel size, it's about overall rolling diameter and weight. I keep buying wheels that I have no I keep buying wheels that I don't have vehicles to bolt to. The other thing that you'll notice is that these wheels, unlike say this wheel has some little washers that kind of sit in when you put your wheel nut in. It's kind of, the wheel nut has a the part of the wheel nut that contacts the wheel is flat. And the steel washer is a steel washer that sits against the wheel and it just tightens up, whereas this wheel has what's called an acorn. So it's a countersunk wheel, that's on a chamfer. And this wheel actually has steel inserts inside the wheel centre. You might be able to see it better on this. Has steel inserts in and they're actually chamfered. And the reason for that is a countersunk bolt is much stronger than a bolt that just sits on the surface. So the wheel nuts in this wheel are much stronger and it's a much stronger connection with the car than those wheels. And that's something to consider. Like I say, if you're going to be putting a lot of stress through a set of wheels, because everything that you do, you know, braking, cornering, accelerating, it all happens through your wheels and it all happens through your tyres. And wider tyres aren't necessarily better. One of the problems with really light cars is that you struggle to get heat into your tyres. And obviously that's weight, that's all rotational weight. I've talked about weight a bunch in this video with all of these different wheels, right? And there is a myth that if you have lighter wheels, then shaving 1 kilo off your rotational mass is the equivalent of shaving 4 kilos off anywhere else in the car. Which is kind of true. Rotational mass, or unsprung mass, right? Unsprung mass is anything that is not supported by your suspension. So kind of your car and the car's body and the body panels, the interior, the engine, transmission, all of that stuff, that's all supported by the suspension. The wheels, the brakes, the tyres, your wheel nuts, the hub, the suspension upright and the suspension arms are not supported by the suspension. They are supported by the ground, obviously. And a lot of people say that removing 1 kilo from all of that assembly is the equivalent of removing 4 kilos from anywhere else in the car. It's kind of true. But one thing that it's kind of true, it's an oversimplification. In braking, a bigger wheel puts more stress on your brakes. But obviously, if you're running teeny tiny wheels, it's because you've got a really lightweight car. Bigger wheels require bigger brakes, which you usually find for a heavier car, which is why every single car now rides like rubbish. The suspension quality on everything on all modern cars is now terrible, and the reason is they're all super heavy. A Twingo is like 1,200 kilos. It weighs twice as much as Pandora will with a full interior. And the reason for that is it's all full of safety stuff and all of that. It's full of electronics and all the rest of it. But all that weight has to be stopped, so you need a really big set of brakes. And big brakes require big wheels, which means that you end up with no sidewall. So your suspension characteristic of your car is all in the spring and the shock, not in the tyre. Which is a bit of a problem, because then you end up with less grip, which means you need to go for a bigger wheel again, which means a wider wheel. So it's not as easy and simple and cut and dry as just bigger wheel better or smaller wheel better. The wheel and tyre package for your car has to be designed for that car, which is why you choose your tyre for the weight of your vehicle and the power of your vehicle, and you work from the tyre to the wheel and in, not you build the vehicle and then you fit the wheels and tyres to it, and if you have to cut a bit away, you cut a bit away. That's not the way to design a car. And unfortunately, that's kind of the situation that a lot of OEM manufacturers, a lot of car makers are in at the minute. They kind of have to put all this weight in the cars, and electric cars are even worse for it. In fact, there was a study in China where they discovered, and don't forget that China make a lot of batteries, so they have no reason to lie. But China discovered that a lot of the pollution actually generated by modern cars is through the brake dust and the tyre dust. Because obviously, modern internal combustion engines are super efficient. If you drive a new 911 Turbo S through an inner city that's very polluted, such as Los Angeles, the air coming out of the exhaust pipe is cleaner than the air you are breathing. And so it's the weight of vehicles that are now causing pollution, and that's a huge problem. So what's the takeaway from this? Well, aluminium is not always stronger, and steel is not always heavier. Wider is not always better. In fact, if you have a lightweight car, you might have less grip with wider tyres, because in cold weather or the wet, you might not be able to get the heat into the tyres. Remember, if you have a 1,000 kilo car, then that's only 250 kilos per corner. My 2CV Pandora that drives around on these skinny boys is just 125 kilos sat on that contact patch. And so if I put super wide tyres on it, they would forever stay stone cold. Right. If you have any comments or questions, damn it, nearly knocked that over. If you have any comments or questions, please leave them down in the comment section below. If you've enjoyed this video, then don't forget to hit the like button, because it really helps. And if you want to see more videos like this, tell me down in the comment section below, and think about clicking subscribe on your way there, or click on the button that looks like my face that'll be there probably. Thank you all for watching. Please be awesome to each other, and I'll see you all in the next video. Bye bye.